G'day again, just another video of a second example of this because there's a bit of confusion. So here we go. So again, given that the domain of cos is restricted from 0 to pi, find the implied domain and range of this big function y here. Okay. So again, I've got an inside function and an outside function, and so I'm just going to draw them to try and get an idea of what's going on. So the two functions, let's just quickly draw them. Now we've got the outside function, tan negative 1. So tan negative 1 goes like this, like that, with our asymptotes at pi on 2, negative pi on 2. So there's my tan negative 1. Just a little rough drawing of this. And the inside function cos x restricted from 0 to pi. So from pi, 1, negative 1. Okay, so that's what those two functions look like. So remember from the last video that what we're looking for this to be defined, that we need the range of the inside function to intersect with the domain of the outside function. So let's just write those two things down. Okay. So firstly, let's have a look at the range of the inside function. The range of cos x. What is that? So here's our graph of cos x. What are the range of values that we get here? Well, the range goes from 1 to negative 1. So there, that's our range right there. Range of cos x goes from 1 to negative 1. And then we need to match that, we need to intersect that with the domain of tan negative 1x. So what's the domain of tan negative 1x? So the x values that are defined here. In fact, tan negative 1x is defined for all r. And so I'm just going to delete that. And it's just defined for r. Great. So where do these two things intersect? Okay, so therefore we're going to restrict. Restrict the domain of tan negative 1x to, so basically, where do these two things overlap? Well, that's defined for all r, so he's pretty easy going. But cos x is only in here. So to make them work for both of these two things, we need to restrict the domain of tan negative 1x to 1, negative 1 to 1. Okay, so that's where they're both defined. I could write down this, I'll do it, but we're not actually restricting anything. And we're also going to restrict the range of cos x to negative 1 to 1, but we haven't actually changed anything. So just on my graph, I'm going to show where that's defined. So the domain of tan negative 1x goes from negative 1 to 1. So let me just draw that in. So we've got negative 1 there and 1 here, and it's going to be defined in here. So that's where we're going to restrict it to. Everything else gets chopped, and the range of cos x goes from negative 1. So we're actually talking about the entire thing here. Okay, so the entire thing, the range, we're including the whole thing. Nothing gets chopped for that one. Okay, so let's just put this together. We want the domain of this whole function now. And so let's just look at this. The range of cos x goes from negative 1 to 1. In other words, we know that cos x needs to go between 1 and negative 1. Again, I'll do it algebraically, but you can just look at the graph. If the range goes from 1 to negative 1, what's the domain of this particular? What are the range of x values? It's going to go from 0 to pi. I'll do it algebraically though as well, just to show you. So cos negative 1 apply to both sides. Cos negative 1 of 1. In other words, where is cos equal to 1? That's at 0. And where is cos negative 1? That's at negative pi. Okay. So in fact, what have I just done? Where is cos equal to negative 1? That's at pi, sorry, or at negative pi. Apologies. And because it ranges between those values, I'll just rewrite this. X ranges between pi and 0. Okay, and we can see that from the graph as well. You don't really need to do this, but anyway, that's it. So that's my domain. So my domain is from 0 to pi. Okay, so for my range, we need to look at this graph. So again, let's look at this graph. My tan is now only defined from here to here, and so I need to figure out what my range is. In other words, what is this here, my range from there to there. We don't actually know these points, but it's where x, well, tan negative 1 is. So what basically the range is going to be between tan negative 1 of 1 up here, so that'll be that point there, and tan negative 1 of negative 1. Okay, so that'll give us that point down here. So let's just figure that out. So tan negative 1, 1, that will be equal to pi on 4. So if we draw our circle, tan is equal to 1 here. And tan negative 1 of negative 1, that'll be down here, and that'll be equal to negative pi on 4. So this is actually, so if I just draw the coordinates on here, that would be the point negative 1 and negative pi on 4. And the coordinates up here would be 1 pi on 4. So what's my range? The range of the whole function will be the range between negative pi on 4 to pi on 4. Okay, and so that's it. So just to summarise, let me just go through that again. So you're looking at the, when you're beginning at this, just sketch them, it will help. You've got an inside function and an outside function. For the entire function to exist, to be defined, you need to match the range of the inside function with the domain of the outside function. Once you've overlapped them and come up with the domain and range that you're restricting it to, so you restrict both of those to that, then maybe sketch it on the graph and have a look at that. And what you're looking for is for each of the functions, for the domain, you're looking at the inside function to be defined. So in this case, cos x was the inside function. Where is that defined? What x values? Well, from 0 to pi. That's where the x values are defined, and that gives you your domain. Then you look at the outside function. Where is the range of that defined? That is between those 2 points there. Where in this case, we just had to figure out what those points were, negative pi on 4 to pi on 4. Please come and ask me if this is still confusing. Sorry about the quick explanation in class.